Alright, hi everyone. Let's continue with our data structures and algorithm series. And today we are going to see another data structure, that is linked list, and more specifically singly linked list. We will see how singly linked list store data and how it is efficient than other data structures. Alright, so it's a type of data structure in which we can store a number of elements, and those elements can be anything: numbers, strings, boolean, etc., just like arrays, right? As we can store a collection of data in arrays, in the same way we can store a collection of data in singly linked list. Now you must be thinking, then what's the difference, right? We can store a collection of data in arrays, then why we need a singly linked list? So the difference is, in arrays we have index numbers for each element, which helps us in maintaining the order of them, right? For example, you can see I'm having an array here of 7 elements, and each element has its index number, and by using these index numbers we can easily get the elements by their position. Like if I ask you to give me the element at third index, then you can simply return 9 as the output, right? But in linked list we don't have these index numbers. Instead, here each element stores reference to its next element. Meaning, let's suppose this is my linked list and this is my first element that has value 10. Now here we don't have any index number, but this element 10 has the reference, or you can say a pointer, that is pointing to the next element. Same with our second element that has value 5 and a reference or a pointer to the next element, that is 7, and so on. Like 7 is pointing to 9, 9 is pointing to 4, and this chain keeps on going until the last element. Now since here in linked list each element has a value and a reference to the next element, we will call this element a node that consists of data and reference to the next element. And if there is no next element, then it will reference to null, which in this case happens to the last element, which is 1 here, because we do not have any other element next to it. It will be referencing or pointing to null. Also, since we are talking about singly linked list, in singly linked list nodes are connected only in the forward direction. Like 10 is referencing to 5, 5 is referencing to 7, but 7 is not referencing back to 5. So it's a singly linked list which is pointing in the forward direction. We also have doubly linked list that takes care of this problem as well, but we will talk about it in some other video. Alright, now since we know how linked list looks like, let's see some operations that we can perform on linked list. The first one is getting elements in linked list or singly linked list. So the ask is get the fourth element from this linked list. So we have already given a linked list here and we have to get the value of fourth element in this. If you remember, in arrays we can simply do that by just passing the index number, but in linked list that's not how it works. So what we need to do is we have to iterate over each node one by one. Let's see it visually. So if we look at this linked list, the fourth element is 9, right? So we have to return 9 as our output. But how can we reach here? Now as we know, each node in a linked list has a value and reference to the next element. So we have to start from the beginning here, from the first node. So we will select the first node and then we will check the reference of it. It is referencing to the second node that has value 5. And then we will check the reference of this second node and it is referencing to the third node that has value 7. And then we will check the reference of third node, and finally we reach our desired node that has the value 9, and we will just simply return it. So as you see, in order to reach to a node, we have to iterate over the nodes that are before our desired node. Think of it like a building that has 7 to 8 floors and you have to reach the 4th floor, but there is no lift in that building. So what you need to do, you have to take the stairs, and one by one you will cross the floors. Like you will reach the first floor and then second and then third, and then your desired floor, that is the 4th floor. In the same way linked list works. If you want to reach the 4th node, you have to cross all the nodes that are coming before that desired node. But the same thing in arrays is quite simple, right? It's like a building and you have a lift and you want to reach to the 4th floor, you can simply press the 4th floor button and you will reach there. That's where arrays wins over linked list. But now let's see some other operations where linked list wins, and that is insertion and removal of elements. Let's see how visually. So if I ask you to insert 0 at 4th position, which will be your third index, then again what we need to do is iterate over the nodes one by one. Like In this case, we will go to the first node and take the reference and move to the second node that has value 5, right? And then take the reference from this node and move to the third node. And as the ask was add 0 at fourth position, which means the fourth node, and currently we are on the third node. So what we need to do is create a new node and assign the value 0 to it, and after that I added the reference to this new node into the third node, which means now the third node is referencing or pointing to the new node that has value 0 instead of pointing to the node that had value 9. So the ask is already fulfilled here. We have added 0 at fourth position, or you can say the fourth node, but we are missing one thing here. If you see, previously this third node was referencing or pointing to the node that has value 9, but now it is pointing to the node that has value 0, which means we have lost the reference or pointer to this node. Now in order to save the chain and save the rest of the linked list, what we need to do is we need to put the reference of this node that has value of 9 into our new node that has value 0. So the final output will look something like this. 7 will point to 0 and 0 will point to 9, and rest of the linked list will remain unchanged because 9 will still reference or point to the 4 and 4 will keep on pointing to 6 and so on. So the major part in insertion was to create a new node and make sure the previous node reference or points to this new node, and this new node will have the reference of rest of the linked list. That's it, and that's how insertion works in linked lists. But now you must be thinking how it is better than array insertion. So if you remember, when we add a new element in the middle of an array, we have to shift the rest of the elements by one index, right? If I show you an example, let's say this is the array. Now if I have to add 0 at index 3, then we have to move all these elements by one index. We have to move 9 to 4th index, we have to move 4 to 5th index, and so on. So you can see we have to perform a number of operations here in order to add a new element. Whereas in linked list, what we need to do is just put the reference of new node into the n-1 node, where n is our desired position, and make sure your new node points to the next node. And we don't need to change anything in the rest of the linked list elements. They will remain as it is, and it will save some operations. And that's how insertion is efficient in linked list than in array. Same thing happens when we have to remove an element in linked list. So if I ask you to delete element 9 or a node that has value 9 in the given linked list, then you have to perform this. Again, you have to iterate over the nodes. Like first we will visit the first node, and from there we will take the reference to the next node, which is our second node, and then we will take the reference from here and move on to the third node. And remember, we have to keep on checking the values, right? We have to delete the element that has value 9, and once we reach the fourth node, you will see the value matches here, right? Now what do we need to do in order to delete this node? What if I remove this pointer where node 7 is pointing to node 9, and instead I directly point to node 4 from node 7, which means we are just breaking this pointer and directly combining node 7 and node 4. In this way, node 9 will be lost, which means we have successfully removed node 9 from our linked list. And that's how we remove elements from linked lists. Simple, right? All we need to do is directly connect 7 with 4, and no need to change rest of the nodes in our linked list. They will remain as it is. That's the beauty of linked list, right? Whereas in array you have to shift all the elements by one index in order to maintain the index numbers for each element. Alright, so those were some common operations that we will be performing on our linked list. Though we have already discussed how linked list is better than array in our previous discussion, let's see it one more time. So as we all know, in linked list there are no unnecessary shifting during insertion and removal of elements. We just need to update the reference of neighbor elements, and that's all. No unnecessary operations, and we will have good time complexity. On the other hand, in array, if we remove one element, then we have to rearrange rest of the elements to maintain their index numbers. But again, there is one operation where array wins, and that is to get the elements. You can get elements by just passing index numbers in array, whereas in linked list you have to iterate over all the nodes in order to get the desired node. Alright, that's all for the theory part. In our next video, we will try to implement linked list in JavaScript, and we will be using classes to implement linked list. And if you need a refresher on JS classes, then you can refer to my last video where I have covered the class syntax in JS and how it works. That's all for this one, and thanks for watching.